Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between batch processing and stream processing. Data types in batch processing, bounded static data set accumulated over time a batch. Stream processing, unbounded continuous data as flow a stream data access. Batch processing processes all the data at once in large volume. In stream processing processes data incrementally as it arrives piece by piece. Latency batch processing high latency from minutes to hours, days. Data freshness is not real time. Stream processing low latency from millisecond to second near real time insights output. Batch processing a compute complete output file result generated after the entire batch is processed. Stream processing a continuous flow of result corresponding to the incoming data points. System focus batch processing throughput processing maximum data over time is the key metrics. Stream processing speed and low latency are the key metrics. Failure handling, batch processing easier to handle failure, simply rerun the entire batch job. Stream processing more complex, requires sophisticated system. Example Kafka Flink to ensure exactly once processing and state management use case. Batch processing in of the day financial calculation, monthly payroll, large scale data transformation ETL, stream processing, fraud detection, stock market trade analysis, live sensor monitoring, dynamic pricing. Key technologies, batch processing, Apache Hadoop, MapReduce, Apache Spark, often used for both stream processing, Apache Flink, Apache Kafka, Streams, Amazon Kinesis, Google Data Flow. Moving question difference between model evaluation and model monitoring. Timing performed once after model training and before deployment. Model monitoring performed continuously after the model is deployed to production. Primary goal model evaluation to assess the model performance and generalization on the static test set. Model monitoring to track the model performance and data integrity in a live dynamic environment. Data used static test set labeled data that the model has never seen. Model monitoring live production data unlabeled constantly changing input data and observe outcomes. Key metric type model evaluation, performance metrics, accuracy, F1, RMSE, AUC, etc. Model monitoring, operational metrics, latency, throughput, and drift metrics, data drift, concept drift, performance degradation, focus. Model evaluation, does the model work on unseen data? Focus on the predictions quality. Model monitoring, is the model is still working as expected with real world data? Focus on stability and relevance. Feedback loop model evaluation, one time calculation to determine if the model is production ready. Model monitoring, continuous loop to trigger alert, retraining or rollback when issues arise. Action taken, model evaluation, accept, reject the model for deployment or return to retrain. Model monitoring, alert, automatic retraining or rollback to previous version. Risk mitigation, model evaluation mitigates the risk of deploying an underperforming or overfitting model. Model monitoring mitigates the risk of model decay and concept drift over the time. Moving to question difference between bias and variance. Definition: bias, the error introduced by the approximating a real world problem which may be complex with simpler model. Variance, the error introduced by the model sensitivity to small fluctuation in the training data. Impact on the prediction. Bias lead to systematic error. The average prediction is consistently far from the true value. Variance lead to large scattered in prediction. The model performs very differently on the small data subset. Model fit. Bias associated with underfitting. The model is too simple to capture the underlying structure. Variance associated with overfitting. The model is too complex and capture noise in the training data. Error type. Bias. High bias leads the high training error and high test error. Poor generalization, where high variance leads low training error but high test error. Poor generalization. Learning curve. Both training and validation error curves convergence to high value and plateau. Variance. Training error is low but validation error is significantly higher with a large gap. Remedies. Bias. Increase model complexity. Example, add features, use a more complex algorithm like CNN GBM. Variance. Decrease model complexity. Example, use regularization, prune trees, gather more training data, use ensembling like bagging. Model type. Tendency. Bias. Simple model. Example, linear regression. Bias tend to have high bias. Variance. Complex models. Example, deep decision tree. High degree polynomial regression tend to have high variance. Trade-off rule. Bias is one component that must be reduced in the optimal model. Variance is the other component that must be reduced in optimal model. Moving question. Difference between precision and recall sensitivity. Primary question. Of all the items we predicted as positive, how many were actually correct? In recall, of all items that are actually positive, how many did we correctly identify? Formula. The true positive divide by true positive plus false positive. Recall. True positive divide by true positive plus false negative. Focus. Focus on minimizing false positive type 1 error. Recall. Focus on minimizing false negative type 2 error. Impact of high value. High precision means the model is reliable when it predicts the positive classes. Recall. High recall means the model misses fewer actual positive cases. Interpretation of error. Precision measures the cost of being wrong about a positive prediction. Recall measures the cost of failing to detect actual positive cases. Use case. Spam filter. Precision. High precision is needed. You don't want to mistakenly flag an important email as spam. Recall. High recall is not the primary focus. Some spam is tolerable. Use case. Disease detection. High recall is critical. You don't want to miss a single actual disease case. False negative. High precision is less critical. A few false alarm, false positive are tolerable for follow-up test. Combined metrics often optimize together using F1 score, which is harmonic mean of the two. Recall often optimized together using the F1 score. Moving question. Difference between feature store and data warehouse. Primary goal to feature store to serve machine learning models with consistent curated feature for training and inference. Data warehouse to support business intelligence repeating and broad analytical queries. Data type. Feature store data that has been transformed into model feature. Example, rolling average encoded categorical variable. Data warehouse stores historical, aggregated, and raw business data. Example, sales, inventory, customer table. Data freshness, highly optimized for low latency and real-time feature delivery. Data warehouse optimized for periodic batch update. Daily hourly freshness is not real-time access pattern. Feature store designed to point in time lookup, key based retrieval of features for single sample or user. Data warehouse designed for complex analytical join and full table scan for reporting. User base, feature store, ML engineer and data scientist, data warehouse, business analyst, and BI user. Consistency focus, feature store enforce training serving priority, ensure the same feature calculation logic is used in production as in training. Data warehouse enforce data consistency across different business unit for reporting. Underlying tech, feature store often uses two-tier structure, low latency online store, example Redis, and high throughput offline store S3 BigQuery. Data warehouse typically used a single centralized RDBMS or cloud data warehouse, example Snowflake. Evaluation, a relatively new component in the ML ops lifecycle, solving the problem of feature logic proliferation, profilification, a mature component of data infrastructure since 1980. Please like, subscribe, and share the channel. Thank you.